So in previous lecture we have started the chapter Gravitation for BSc first semester 1, and the today's topic is the motion of satellite in orbit around Earth. So today we will see what is the equation of velocity of satellite when it moves in particular radius around the Earth surface. So topic is very interesting, and simultaneously after over of this topic we have to see the application of satellite. So this topic today we have to cover. So these two topics in today's lecture we have to cover these two topics. So first upon we'll see the motion of satellite in orbit. So let us see one by one. So topic is very interesting, and we have to derive an equation for the velocity of satellite moving in circular orbit around the Earth surface. So for this we will consider a satellite of certain mass, say small m, which is moving around the Earth surface. So we'll write the initial few lines for the motion of satellite in orbit. Before starting this topic, let us draw a small diagram. Suppose this is our Earth, and small capital M is the mass of Earth. Now I will draw one orbit. Suppose this is the center of Earth, and satellite is moving around the Earth, which is at height h from the center of Earth, and small v is the linear velocity of that satellite. Now what is the linear velocity in this diagram? If any body is moving in circular orbit, at every point it has velocity vector, which is its linear velocity. So this is the linear velocity, and suppose I will say small m is the mass of satellite. Now another factor I will write here, capital R is the radius of Earth. So simple, satellite of mass m is moving with velocity v around the Earth surface. Earth has radius capital R, and capital M is the mass of the Earth. So this is very simple diagram. So our topic is the motion of satellite around Earth surface. So we have considered the initial parameters. So we'll write, let us consider a satellite. Now this is an artificial satellite. Our moon is the natural satellite. सगळ्यांना माहित आहे आपला जो moon आहे, it is a natural satellite. So we are considering the artificial satellite here. Why we are considering the artificial satellite? Because we know that for our applications, for various applications, we are launching the artificial satellites, and artificial satellites are launched in India from the satellite launching station. Basically the Indian Space Research Organization ISRO is doing that work. It is headquartered in Bangalore. So we are doing the job for our applications, and why we are doing that we will see later on. What are the applications of satellite? We are doing this for communication purpose, for military purpose, for navigation purpose, then for mobile communication, for television communications. We are doing this work. So let us see what are the initial factors which are involved in the satellite motion. So I will consider, let us consider a satellite of mass small m is moving in an orbit of radius capital R plus h around the earth's surface, around the earth's surface. Now why this is R plus h? Now in this diagram we have assumed capital R is the radius of earth, but satellite is at height h from the earth's surface, so total radius will be R plus h. So orbital radius of the satellite, I will write here, R plus h is the orbital radius, of satellite. म्हणजे सॅटेलाइट ची जी फायनल ऑर्बिटल रेडियस काय आहे, अर्थ ची रेडियस प्लस height of satellite. Now very basic concept comes in mind that if any body is revolving in circular orbit, according to law of gravitation, there is a gravitational force acts between these two bodies, where m is the mass of earth, m is the mass of satellite, this distance is r plus h. So according to Newton's law of gravitation, the gravitational force which acts between these two bodies, capital M and earth, capital M and small m. So gravitational force obviously acts between these two bodies. So we can write the gravitational force which acts between these two bodies is according to Newton's second law of gravitation. So we have seen that in previous lecture. Now first upon, I will ask a question to the students. How many forces acts between these two bodies, capital M and small m? This capital M is the earth and small m is the mass of satellite. So basically you might have been studied in 12th science the centripetal force. If any body moves in circular orbit, the centripetal force acts between these two bodies, and this direction of centripetal force is towards center of circle. So what is the centripetal force provided by this satellite? So we'll write down. So it is complete up to this. The two forces acts between satellite and earth. याच्यामध्ये दोन फोर्सेस आपल्याला क्लिअर कट दिसत आहेत पहा. पहिला फोर्स, द सेंट्रिपिटल force provided by satellite, the centripetal force provided by satellite. And second, the gravitational force acting between satellite and earth system. So clear cut आपल्याला दोन फोर्सेस इथे दिसत आहेत. जर कोणतीही बॉडी सर्क्युलर मोशन्स मध्ये असेल, because satellite is orbiting in circular motion around the earth, so these two forces basically are involved in this system. So what is the centripetal force acting? So centripetal force acting on satellite, we will write mathematically. So we will write mathematically. We have mathematical expression for centripetal force and gravitational force. In previous lecture we have studied mathematical expression for gravitational force by Newton's law of gravitation, and already we know that centripetal force which acts on the system can be calculated. So first upon the centripetal force acting on satellite. First is a centripetal force acting on satellite due to circular motion So I will write centripetal force CF and I will denote it by symbol F1. We know that is the universal equation, mv square upon r. This is the centripetal force. So I will write mv square upon r plus h, because this total radius is capital R plus h, where capital R plus h equal to r, and I will denote this by equation 1. So this is the centripetal force. Equation for centripetal force. Now second force कोणता ऍक्ट होतोय आपण जस्ट पाहिलं, द ग्रॅव्हिटेशनल फोर्स acting between satellite and earth system. मग आपण तो ग्रॅव्हिटेशनल फोर्स कोणत्या लॉने देतो? इट इज गिवन बाय न्यूटन्स सेकंड लॉ ऑफ मोशन. According to Newton's second law of motion, ग्रेविटेशनल फोर्स हम एक्सप्लेन करेंगे. तो क्या है उसका इक्वेशन फॉर ग्रेविटेशनल फोर्स F2 is gmm upon r square. That is universal equation of Newton's law of gravitation. So this is r square. So what is this r? ये है r plus h, that is total distance between center of earth and height of satellite, that is F2 equal to gmm r square. This is the gravitational force GF. सेंट्रिपिटल ला मी CF म्हटलं होतं, ग्रॅव्हिटेशन ला मी GF म्हटलं आहे. Now look here, the two forces are involved. First is the centripetal force and second is the gravitational force. Now always remember the equilibrium or the stable orbit of satellite. या सॅटेलाइटची जर स्टेबल ऑर्बिट आपल्याला पाहिजे असेल तर देयर शुड बी टू फोर्सेस शुड बॅलन्स विथ ईच अदर. सो आय विल राईट फॉर स्टेबल ऑर्बिट, फॉर स्टेबल सर्क्युलर ऑर्बिट, the two forces must balance. The two forces must balance with each other. Must balance. जर आपल्याला स्टेबल सर्क्युलर ऑर्बिट हवी असेल तर दोन्ही फोर्सेस बॅलन्स मध्ये पाहिजेत. म्हणजेच काय, टू फोर्सेस बॅलन्स मध्ये असतील म्हणजे काय, टू फोर्सेस शुड बी इक्वल, isn't it? So we'll write it, that is two forces मस्ट बी इक्वल, दोन्ही फोर्सेस आपल्याला इक्वल पाहिजेत. म्हणजेच काय आपण लिहू शकतो, दॅट इज सेंट्रिपिटल फोर्स CF, आपण त्याला F1 म्हटलं, शुड इक्वल टू ग्रॅव्हिटेशनल फोर्स, आपण त्याला F2 म्हटलं, इजंट इट. मग सेंट्रिपिटल फोर्स काय आला आपला, mv² अपॉन r, आणि ग्रॅव्हिटेशनल फोर्स काय आला आपला, G कॅपिटल M स्मॉल m अपॉन r². एक r कॅन्सल झाला, स्मॉल m कॅन्सल झाला. So finally, what is the velocity of the satellite in orbit? That is velocity v² equal to gm upon r, isn't it? That is velocity v equal to square root of gm upon r. आपण याला equation 2 म्हणू. We'll call this as equation 2. So this is the velocity of the satellite, that is linear velocity. This is the linear velocity because at every point there is a linear velocity. So very simple. So what we can say from this equation 2, the linear velocity depends on mass of Earth and radius of orbit. What we can say, the linear velocity यालाच म्हणतात orbital velocity. Always remember, this is the orbital velocity, more precise. The orbital velocity depends on mass of Earth, depends on mass of Earth and radius of orbit. Radius of orbit कशावर डिपेंड नाही, linear velocity, this orbital velocity doesn't depend on mass of satellite, that is small m. So we can write here, the orbital velocity doesn't depend on mass of satellite. Very important concept. Orbital velocity कशावर डिपेंड आहे, it depends on mass of Earth and radius of orbit. So here small r is the radius of this complete orbit of satellite, that is r plus h. So orbital velocity doesn't depends on mass of satellite. So this is very important expression. I will make box for this equation 2. Now if I will consider this distance h is very negligible, so I can say when satellite is very close to the earth surface. So this is the special case. What is the special case? When satellite is close to the earth surface, जर सॅटेलाइट एकदम अर्थच्या जवळ असेल तर आपलं एक्सप्रेशन कसं मॉडिफाय होईल. मग सॅटेलाइट एकदम अर्थच्या जवळ असेल म्हणजे काय, एकतर तो अर्थच्या डायरेक्ट सरफेस वरती असेल, it is directly on the earth surface. For example, say I am standing on the earth surface. मी अर्थ वरती उभा आहे, म्हणजेच माझ्यावरती कोणते फोर्सेस ऍक्ट होतील, which two forces will act on my body or on satellite when this satellite is very close to the earth surface. Remember, meaning of close to the earth surface means what? क्लोज म्हणजे किती क्लोज, एक तर तो अर्थच्या सरफेस वरती असेल किंवा एका छोट्याशा ऑर्बिट मध्ये असेल. मग आपण खूप क्लोज म्हटलं, फायनल कंडिशन काय असेल, इट इज ऑन दी अर्थ सरफेस. It is on the earth surface. It is on the earth surface. It is on the earth surface. So when satellite is on Earth's surface, two forces will be evolved. परत त्याच्यामध्ये दोन फोर्सेस असतील. पहिला असेल वेट ऑफ द सॅटेलाइट, वेट म्हणजे त्या सॅटेलाइटचं वजन, वेट ऑफ सॅटेलाइट, आणि दुसरा असेल ग्रॅव्हिटेशनल फोर्स. ग्रॅव्हिटेशनल फोर्स ऍक्ट्स इन एनी पोझिशन, and second is gravitational force. Now remember again, when satellite is on the earth's surface or any body is on the earth's surface, suppose I am standing on the earth's surface, I am giving lecture to you by standing on the earth's surface, isn't it? In this studio I am standing on the earth's surface. I am in studio, but I am finally on the earth's surface. This studio is on the earth's surface and I am also on the earth's surface. Now on my body how many forces will act? My weight, माझं वजन डाउनवर्ड असेल towards center of earth, and gravitational force obviously it will act at any position. So I am here, I am giving lecture with a stability, I can say. मी तुम्हाला लेक्चर स्टॅबिलिटीने देतोय, म्हणजेच काय, माझी पोझिशन स्टेबल आहे. म्हणजेच काय, मी स्टेबल कधी राहू शकतो अर्थ सरफेसवरती, म्हणजे सॅटेलाइट अर्थ सरफेसवरती स्टेबल कधी राहू शकतो, इफ these two forces balances with each other. When these two forces balances with each other. मग weight of satellite काय येईल? We know that formula of weight W equal to mg. W is equal to mg. So I will write weight of satellite mg equal to, what is the gravitational force between satellite? gmm upon r square. So again this m will get cancelled, and small z equal to gm upon r square. Very important expression. That is capital Gm equal to Gr square. Are you getting this? Very simple. Now question comes in mind, what will be the velocity on Earth surface? आपण velocity orbit मध्ये कॅल्क्युलेट केली. किती आली आपली? अंडर रूट Gm अपॉन r. सॅटेलाइट एका ऑर्बिट मध्ये असेल तर त्याची वेलॉसिटी आपल्याला ही आली. मग जर सॅटेलाइट अर्थच्या सरफेस वरती आला तर त्याची वेलॉसिटी किती असेल? दॅट वी हॅव टू ऑल्सो टेक इनटू अकाउंट. सो फॉर दिस पर्पज वी विल यूज इक्वेशन. आपण याला इक्वेशन 2 म्हटलं होतं. युजिंग इक्वेशन 2, so what is our equation 2? Velocity equal to Gm upon small r. So I will put value of this Gm here. So first of all I will do squaring both side. दोन्ही बाजूचं मी स्क्वेअर करतो. Squaring both side. So v square equal to स्क्वेअर रूट निघून जाईल. स्क्वेअर रूट तुमचा निघून जाईल. मग v स्क्वेअर काय येईल? gm काय आहे? gr स्क्वेअर अपॉन r. मग तुमची वेलॉसिटी काय आली? v स्क्वेअर 1r will get cancelled. gr. But on Earth's surface तुमचा हा स्मॉल आर काय होईल? स्मॉल आर म्हणजे आर प्लस एच आहे, म्हणजे एच निघून जाईल. बट ऑन अर्थ सरफेस आर विल बी रेडियस ऑफ अर्थ. सो व्हॉट विल बी द वेलॉसिटी फायनली? the velocity finally would be v square equal to gr and velocity equal to square root of gr. Very important. So when satellite is on Earth's surface, its velocity is independent on mass of Earth and mass of satellite. Very important statement. So I will write, आपण ऑर्बिट मध्ये असताना सॅटेलाइटची जी व्हेलॉसिटी असेल इट डझंट डिपेंड्स ऑन मास ऑफ सॅटेलाइट. हे आपण पाहिलं इक्वेशन 1-2 मध्ये. पण ज्यावेळेस सॅटेलाइटला आपण अर्थच्या सरफेस वरती घेतो त्यावेळेस इट्स व्हेलॉसिटी डझंट डिपेंड्स आयदर ऑन मास ऑफ सॅटेलाइट और ऑन मास ऑफ अर्थ. सो वी विल राइट what is the conclusion from this? The velocity of satellite on Earth's surface doesn't depend on either mass of satellite small m or mass of earth capital M. याला आपण इक्वेशन 3 म्हणू. So from equation 3 we can say that the velocity doesn't depends on the mass of earth and mass of satellite. So understood this concept. So what we have seen in this concept we have seen, आपण काय पाहिले याच्यामध्ये, एक आपण सॅटेलाइट कन्सिडर केला, त्याचं मास स्मॉल m आहे, तो अर्थच्या ऑर्बिट मध्ये फिरतोय. तर त्या ऑर्बिट मध्ये फिरत असताना त्या सॅटेलाइटची व्हेलॉसिटी काय असेल ती आपण इक्वेशन 2 ने पाहिली, v = √gm/r. नंतर आपण काय केलं, तो सॅटेलाइट अर्थ वरती घेतला, अर्थच्या सरफेस वरती घेतला, म्हणजे तुमचा h cancel होणार, h will be cancelled, that is height will be 0. So what will the total orbit? Total orbit small r will be capital R, and then we found out what is the velocity of that satellite on the earth surface. आपण त्याच्यावरून कन्क्लुजन काढलं की velocity on earth surface doesn't depends on mass of satellite, either on mass of satellite or on the mass of earth. So understood? Very clear, very simple. So in next lecture we will find out what is the orbital period, what will be the orbital period. So just give headline, the orbital period capital T of the satellite around the earth. So this will be the point of discussion in the next lecture, around the earth. So just to write down this headline. So orbital period means how many hours, what is the time required for satellite for revolution around the earth surface. So that orbital period capital T we will calculate in the next lecture. So today we'll stop here. So this was the very important lecture, and in next lecture we'll start from the orbital period. So thank you all. Thanks.